Okay, so the goal of this lesson is to find the range of piecewise functions. And we're going to start off by kind of reviewing how to graph the piecewise function, and then we're going to talk about the range. Remember, the range is a set of y coordinates that you obtain from the domain. So remember, this is your domain of your piecewise functions. Okay, so remember to graph this function f of x, remember there are two pieces here. So you can use this part if the value of your domain is greater than 2, and you're going to graph this part if the value of your domain is less than or equal to 2. All right, so let's look at the first one. So remember what you did was you first of all you graphed f of x equal x plus 2, or you could have said y equals x plus 2. And so when you did that, let me go ahead and enlarge this. So when you did that, you would get, using a t-table, and so remember you have to use this number. Even though there's no equal sign, you can't include it on the graph, so to speak. You're going to put an open circle. Okay, remember the open circle equal sign would be a closed circle. So if x is 2, I get 2 plus 2, which is 4. Now remember, this is going to be open. So I'm going to plot the point 2, 4, which is here, with an open circle. Okay? Then I need, remember this is linear, so I just need one more point, and so I got to pick a number that's greater than 2. So let's say 4. If x is 4, I get 4 plus 2, which is 6. I'm going to plot the point 4, 6, which is here. All right? And then I draw my ray. This is going to be a ray now. Make sure you start here. Okay, don't draw a line going through this. All right, so you get this. All right, because remember, this piece of the function, this part of the function, is only for values greater than 2. All right, so like 2.004, 2.003, 2 point, and so on. Okay. Now let's look at this one. So now we're going to graph y equals x minus 3. Now remember, I can only use values of x that are less than or equal to 2. So I'm going to use 2 again. Now remember, that's going to be close because of the equal sign. So if x is 2, I get 2 minus 3, which is a negative 1. So I get 2 negative 1, which is here, closed circle. All right, I need one more point because this is linear. Okay, I've got to use a value of x that's in this domain. So let's say 0. If x is 0, 0 minus 3 is a negative 3. So I'm going to plot the point 0, negative 3, which is here. And then I'm going to draw my ray. All right, so remember you start here like this. All right. Okay. Now let's talk about the range. Now, remember when we graphed functions before and we found the range, we went along the y-axis like this. It helps if you use a ruler. Now remember, so I'm going to ask you this question. Remember, range is a set of y coordinates. So if I look at the y value of 10, am I going to get a point on the graph somewhere? Yeah, you will, because this ray keeps on going like this, right? So if this was negative 1 million, I'd get a point on the graph somewhere, right? So I'm going from negative infinity. Now this is where this is going to be important. Okay, so remember the idea of the interval notation. You're going from negative infinity all the way, and then notice for this part of the graph, when we're looking at pieces, you got to deal with this in two separate pieces. So you're going from negative infinity all the way to, and then you stop here, and what is that y value? That y value is negative 1. And notice there's a closed circle here. So the answer, so we'll go ahead and do this right here. All right, so the range will equal, all right, so parentheses negative infinity to negative 1 with the bracket. Now make sure you remember why there's a bracket, because of the equal sign. I'm sorry, because of closed circle, which came from the equal sign. I'm going to ask you this. When y is 1, if you were to continue using a t-table, do you think you'd ever get a y value of 1? Nope, you won't, because there's no part of the graph here, right? So when y is 1, there's no graph in this area. When y is 1.2, there's no graph in this area. So you're going from negative infinity all the way to 1, a negative 1, and then you're going from where? You're going from 4 to what? Infinity. All right, so union, remember the union? So union parentheses, why parentheses? Because of the open circle. So parentheses 4 to infinity. And there's your range. So that's how you find your range. So notice you went from negative infinity all the way to this y value right here, which is -1. And then there's no part of the graph here, so you're never going to get a y value between here and here. Okay? And even 4 is not going to be a y value in the graph because it's open. All right, so you're going from parentheses 4 now all the way to infinity. All right, so remember you had to kind of review something from a previous course when you had open and closed circles. So remember, closed circle, you're going to use a bracket. Open circle, you can use parentheses. And you obviously remember you're going to use parentheses with infinity, negative infinity always. All right, so that was number 1. Okay, now let's look at this. So again, we're gonna kind of review how to graph this, and then number 2, we're going to determine the range. All right, so determine the range of g of x. All right, so notice though that when we did number 1, those two individual parts were linear functions, right? Those were linear functions. Notice in this one, when I look at the first one, y equal x squared, that's a quadratic function. So the graph is going to be, that light is bad here. So that graph, and remember I can only use values of x that are greater than 0, so that graph is not going to be linear, it'll be more of a quadratic, more of a parabolic shape, all right? So I got to use numbers greater than 0 though. All right, so if x is 0, remember that's going to be open because there's no equal sign. When x is 0, what's 0 squared? 0. Now, remember when we did this, I only needed 2 points because it was linear. All right, remember with quadratic, remember you need a few more points. So if x is 1, what's 1 squared? 1. If x is 2, what's 2 squared? 4. If x is 3, what's 3 squared? 9. Okay, and that's about all I need here. So I get 0, 0, open right here, open, because there's no equal sign. 1, 1, 2, 4, and 3, 9, right here. And so when I graph this, I get part of this parabola looks like this, okay? Now let's graph the other part. So the other part is y equals negative x plus 2. All right, so remember, I got to use values of x that are less than or equal to 0. So if x is 0, you got to use 0. This is going to be closed because of the equal sign. So when x is 0, what's the opposite of 0? Remember, negative x means opposite of 0, opposite of x. The opposite of 0 is 0. 0 plus 2 is 2. If x is, I got to pick some numbers. Remember, this is linear, so I just need one more value. If x is, let's say, negative 1. What's the opposite of a negative 1? Remember, you're saying this. The opposite of a negative 1 is what? 1. All right, and then 1 plus 2 is 3. So negative 1, 3, right here. Oh, I forgot to put 0, 2. 0, 2 is right here. That's going to be closed. Negative 1, 3 is here. And let's do one more. If x is, let's say, negative 4. Negative 4. This means the opposite of negative 4. What is the opposite of a negative 4? 4. And what's 4 plus 2? 6. So, I'm sorry, I put this wrong. It should be where? Negative 1, 3 is where? Right here, right? Okay. And then negative 4, 6 is right here. Okay, so then we're going to plot those. Make sure. Okay, negative 1, 3. I'm messing this up, aren't I? So let's do this again. When x is negative 1, the opposite of negative 1 is 1. 1 plus 2 is 3. Okay, so that's right, negative 1, 3. If x is negative 4, the opposite of negative 4 is 4. 4 plus 2 is 6, so negative 4, 6 is here. When x is 0, okay, so that looks like I did this fine. All right, so then the graph. So then when you notice, I noticed right away something's wrong, right? Because when I look at these points right here, they don't lie in the same line. These 3 points I just did don't lie in the same line. So notice when I said 0, 2, but I put 0, negative 2, right? So 0, 2 is here. Sorry about that. All right, so 0, 2 is here. All right, so let's fix that. So then you get this. All right. Okay. Now, so there's the graph of that. Okay, so that's the graph of this. This is the piecewise function. So that's the graph of this piecewise function. Okay. All right, now be careful here because you can easily mess up sometimes when you plot these points. Zero, I'm not sure why I said 0, 2 is here. 0, 2 is right here. That's 0, negative 2, right? Okay, now here's what you got to be careful of. All right, so let's talk about the range. All right, so just like before, you go from bottom up. When I start touching the graph, I start touching it here. But it's an open circle, right? So I'm going to say, now what is that y value here? So I'm on the x-axis, so what's that y value? That y value is 0. So my range, all right, listen to this carefully. My range is going to be 0, okay, open parentheses, all the way to, and then notice right here. Okay, it's okay that for this y value 2, there are two different x values. That's okay. We're still having a function here. So notice I'm going from infinity all the way, and then keep on. You don't stop. You don't stop because there's no gap, right? See right here, there was a gap. So then you had two intervals. See that part? So that's why you had two intervals. There was a gap. I had this piece when I went along the y-axis. I stopped here. There was a whole gap here. So hence that union, and then I continued on. Here, though, I want you to notice as I go along the y-axis, I start here. Is there a gap anywhere between those two pieces? No, there's no gap. You continue, right? You just keep going from here to here. Even though they're two separate pieces, there's no gap between them. There's no empty space between where one starts and the other starts as well, or where one ends and the other one starts. So you go from here all the way to what? All the way to infinity. Okay, and there's your range. So it's very important. You notice that the reason why there are two intervals here versus one interval here. Okay, there are two intervals here because this piece, when you go from along the y-axis, you have a piece, then there's this whole empty space here along the y-axis. See that? There's no graph anywhere around here. You'll see it? And then you have this part. Here, when I start touching the graph, there's this, but there's no empty space here. Notice this ruler. This ruler always touches part of the graph, always. All right? All right, now let's look at the next one. Okay, so first of all, before we go on, remember this was a quick review of graphing. Our goal, though, in this part of the lesson is to determine how do we find the range. All right, so remember the range is a set of y coordinates. All right, so let's look at the next one. All right, that shouldn't be too bad. That's kind of like what we had a while ago, wasn't it? Okay, so I go from where? I go from negative infinity, find the range. So the range will be negative infinity parentheses. Now, do y'all see that this is going to be two intervals because of this gap right here? Okay. So you go from negative infinity all the way to what? What's this y value right here? 2 with a what? Bracket. Union, and then there's a whole space here, empty space, and then I start touching the other part of the graph when I get at y equal 4, parentheses, because of the open circle, all the way to infinity. Okay? All right, so that was that one. Okay, let's look at the next one. So the next one, we have, come on. All right, so the next one, we have this. All right, it's kind of like what we had a while ago, wasn't it? All right, let's think about that. So I start touching the graph when I get to this point right here, right? It's a closed circle, so the range is going to be from, now you remember you look in the range, so that's the y coordinates that you're looking at. So the y coordinate here is 2, a negative 2, bracket. Now, is there, when you continue on, is there empty space anywhere? Is that ruler right here touching every part of this graph? Yeah. Now you might say, well, what's open here? It's open. So why do you put a parentheses? Because remember, you're looking for the y coordinates. So this y coordinate's 2, right? So it's open here, but it's what? Closed here. So that's still, you see this? That's still, 2 is still in my range. Even though it's open here, it's closed here. There's no open circle here. So I can still use 2. 2 is part of my range. So I'm going from negative 2 all the way to what? Infinity. Okay? Negative 2 all the way to infinity. All right, so that was that one. All right, next one. All right, let's look at that one. All right, so here, notice these when we go along the y-axis, there's this ruler right here is touching all aspects of the graph, right? And you might say, but when I get to negative 2, there's an open circle. It doesn't matter, because what do you notice here? It's closed. So negative 2, a y value of negative 2 is still in my range. So I'm going from negative infinity all the way to what? What's this y value right here? 3. So the range is negative infinity all the way with 3 with a, and that's closed, so you're going to have to say bracket. All right, bracket. Okay, next one. All right, what about this one? All right, so you're going from negative infinity all the way to what? Now notice there's a gap, right? So that's 2 intervals. So negative infinity, so the range will be negative infinity all the way to, what's this y value? 2 with a bracket, union. And then notice this ruler doesn't touch any part of the graph. It starts touching the function when I get to this, and that's an open circle. So that's what's this y value? 5. So I'm going to say parentheses 5 all the way to infinity. All right, next one. All right, now some of you are going to mess up on this one if you're not careful. You're going to get one part, you're going to mess up the other part. Okay, so let's find the range. All right, no big deal. We can find the range. Okay, now notice I'm going from negative infinity all the way to what y value? Y value of negative 2. All right, so I'm going to put that here, range. Negative infinity to negative 2 with parentheses, union. All right, now let's think about this. Let's go back over here, and we did this one. Notice when I did this one, I went from negative infinity all the way to negative 1, right? And then notice my ruler isn't touching any part of the graph anymore, so I continue on here, and then I continue on because my ruler's still touching the graph, right? It's still going, right? Okay. So notice you're going from 4 all the way to what? Infinity. All right. Now let's think about this. Here, I'm going from negative infinity all the way to this y value, which is negative 2. I go on, I'm not touching any part of the graph, so all these y values are not in my range. All these y values are not in my range, but then I touch the graph again, right? And I can't go any further. Why can't I go any further? Why? Because this is a horizontal ray. Notice, and what you notice, what are all these y values right here? You've had this in a previous course. We talked about it in this course as well. What are all these y values? Well, these y values are the same, right? What is it? It is 5. So you got to remember now, how do you write the y value of, if there's just one y value here, how do you write it? You write it as this, as a set with just one number. That's how you write it. Okay? So that one's a little bit tricky because it was not a ray that did this, that increased or decreased. It was horizontal. But notice that all these y values, as x gets bigger and bigger, all these y values are the same. So that's how you denote that one y value. There's all these y values are the same, right? And there's just one, it's 5. That's how you denote it. So this is an interval because you're going from negative infinity all the way to negative 2. But then notice all these are not in your range. But then you get here, and you don't go any further. You're not going to go to 6, right? Because 6 is not in my range. There's no part of the graph here. The graph stops here, and it's all of this. And all these y values, remember you're trying to find the range, the y values, all these y values are the same. It's just one number, 5, and you denote that one element as a set with one element. It's a finite set. So this is infinite, this is finite right here. All right, so let's look at another one like that. All right, this one right here. All right, notice those are both horizontal rays, right? Okay, so notice the arrow's horizontal, pointing horizontally. So let's see how we're going to find the range. So the range is equal. Now, here's the way I would write this. So notice when I look at this part of the graph, what is the y value? What are the y values here? They're all 4s, right? Okay, continue on. What is that y value right here? They're all sevens, correct? They're all sevens. Even though there's an open circle here, I still say 7 because 7's here. All these are sevens. All right, now here's how I would write this. The reason why here I had an interval and a finite set, I'm using the word finite set here, finite set, is because this was the interval part, this was a finite part. These are both what? Finite. The y values are both finite here. Finite, finite. So what I would do is just this. Say is just a set consisting of two numbers. What are those two numbers? 4 and what else? 7. 4 and 7. And that's it. All right. Now if you wanted to, you could have said the set 4 union the set of 7. All right. But this is the way we prefer to do that. Okay. All right. So finite, finite. Write it like that. And that should be it. Okay. All right. So that was a quick review on how, well, a review for some of you, depending on the course you've had before. But that was a review or a discussion on how to find the range given the graph of a piecewise function. Okay. All right. So remember, some of you are going to have issues with the horizontal one. So don't let that be an issue. So if you had something that looked like this, let's say, and then this, let me do that here. All right. So notice in terms of the range, you touch this first. That's a finite. That's finite because it's horizontal. The only y values on here is 3, right? So you're going to say 3 union, and you have to do a union here because this is an infinite set of y values. So you're going from -1 with parentheses because the open circle all the way to infinity. Okay? All right, and then if you had this, let's say it was this. Let me go ahead and quickly do this part. Let's say you had this one. All right, now this right here is a tricky one. That's probably the trickiest of all of them. Okay, so notice when we did this one a while ago, this one right here. See this one? So we had 2 parts to it, right? 2 parts because there was a gap. Y'all see that gap? All right, so you had this y value is all the same, so that's where this finite part came right here. And I said 3. This is -3. Sorry, -3, right? Because these are negatives. I can't see those negative symbols here, but that's -3. And then going from -3, and then the other part is from -1 all the way to what? Infinity. Okay. Here, though, I want you to notice. Here, I'm going from -infinity, right? Keep on going. And then notice this is where I stop. Y'all agree? There's no gap here. It's not like if I compare this, watch, if I compare this with this, I'm going to do the same one here. 2, that was 2, 2. I did this. And then let's say I had this. Okay, so I want you to compare this right here with this one. Okay, do y'all agree for the range, I'm going from -infinity all the way to this y value. What's that y value right here? 2. With parentheses because of the open circle. But there's a gap, right? See this gap? So then I'm going to say union, and then what's this y value here? It's horizontal, so all these y values are the same. It's what, 4? Okay, so you see there was a gap here. So you had 2 parts to this. Here, notice, I'm going from -infinity all the way to, and then there's no gap. All right, but what are these y values right here? These y values are what? 2. And you may say, but there's an open circle here. It doesn't matter. Is 2 still in my range somewhere? Yeah, it's right here. All these. You have an infinite number of points with the y value of 2. So for that one, you're going to say negative infinity to 2 with a bracket. With a bracket. You may say, but that's a parentheses. Yeah, but I'm asking you this. Is if you look at your graph, will you ever get a y value of 2 somewhere? Yeah, all right here. You're not going to get it here because that's open, but you still get a y value of 2, and it's right here. Okay, so that one was a little bit harder here than this particular one. Okay, all right, so that should help you somewhat with finding the range of a piecewise function.